In a previous discussion about arrays, we mentioned the following, that if the type of the array is t square brackets, then the type of its element is t. Now, there is nothing that prevents from us from having the type of its element to be an array itself. This is the way that in Java we are creating multidimensional arrays, as they are usually called in other programming languages. Take a look at this statement. We are declaring a variable, an array variable called matrix, and we are giving it two lengths, two dimensions, as you want, if you want to describe it that way. What is the picture that will create? Here is the array that is being created. Remember that the default value for an integer is 0. This is an int array, so every element upon creation gets the default value, since we did not initialize the array with different values. And this is why the picture is full of zeros. What have we created here? One way you can read it, you can understand it, is that this is a two-dimensional array that has 5 rows and 10 columns. A more accurate description in Java is that this array has 5 elements, and each of the elements has 10 elements itself. So matrix I is an array of 10 integers. And here is a picture of this array. Let's take a close look to see what is happening. The array matrix is a reference to an array of 5 elements. Now, each of those elements is itself a reference to an array of 10 elements. So matrix, we said, is referencing an array of 5 elements. Each of those elements, matrix of I, is a reference to an array of 10 elements. So matrix.length will return 5, while matrix of I.length will return 10 in this particular example. To understand the difference between matrix.length and matrix of I.length is quite important, especially when you will have to write your own code where you will be using arrays like this, and you will be using them, say, for example, in a nested for loop, so that you can access each element of the array. Why would you use such two-dimensional arrays? Well, there is a variety of different cases, different applications. For example, many of the board games that you may want to one day write a program for use grids. Another application is when we are trying to figure out distances between pairs of cities, for example. An application from math, matrices in linear algebra. In general, any data that can be represented in a tabular form will actually need to be stored, most likely, in a two-dimensional array. Of course, the fact that we generalized the arrays and we went from 1 dimension to 2 dimensions does not mean that we cannot just add more dimensions if we need them. For instance, you see this line of code on the slide where we have an array with 4 dimensions. We want to be able to capture 3 dimensions for space and also time. Now, do a calculation, pause the video and calculate how many bytes do we actually need in order to store this 4-dimensional array of doubles. You know what is the size of a double. Make the computation to find out the answer. And the answer is just on your screen if you make the right multiplications. If you do not find out this number, make sure to ask a question about it. The way that arrays are, the multidimensional arrays, are implemented in Java creates a very interesting quirk. There is no requirement that matrix of I and matrix of J, if matrix is a two-dimensional array, have to have the same length. Its row could definitely have as many elements as it likes, since the two matrices are completely independent of each other. This creates a very interesting shape if you try to visualize that. We could have matrix of 0 have 3 elements, matrix of 1 have 10 elements, matrix of 3 have 7 elements. In this form, if you visualize that, you will see that it creates a shape, a ragged shape. Now, why would we do that? Why do we get into the pain of actually specifying exactly how many spaces are needed for each of the arrays of matrix of I and matrix of J, instead of just giving to every matrix of I the maximum number of elements that will be needed for any I, and just be done with it? Why do we bother to actually save space? And this is the key. We actually do it for storage reasons. We don't save that much space when we're talking about a 5 times 10 array. But when we're talking about a bulk of data where we have millions of entries, then saving space is much more important.